Hi, in this video I would like to introduce you some interesting functionalities of the Huawei Agile Open Container, in short AOC, and in particular its Python-based Open API. I will quickly introduce AOC for network programmability, then we'll explain what is service package and why it is useful. Finally, I will provide some details on how the service package design can be flexibly and efficiently enriched by using AOC Python-based Open Programmable API and describe some of its reference documentation functionalities. Today, network operators need network programmability in order to support network-level service configurations over multiple network elements at the same time, rapid service rollout and multi-vendor device adaptation via open network programmability with pre-delivery simulations, dry runs, and verifications, and also simplified service interfaces through standardized modeling language, abstract vendor-specific models and interfaces, and simple device models to allow them to focus on network-wide services and user intents. Agile Open Container, AOC, enables these aspects by introducing Yang-based openness and programmability, rapid multi-vendor integration, highly reliable network adjustments, including features like configuration simulation, dry run, verification, transaction rollback, etc. The SSP package in AOC is the mechanism used to describe the network service to be deployed on the network, and it contains a service model, defined in Yang, a set of Jinja templates for southbound mapping, and service-specific mapping code written in Python, which defines how to implement the mapping between the service model and the Jinja templates. This presentation focuses mostly on the Python Open API that can be used to customize the mapping of service Yang model to the network element Yang template. There are multiple sources on the web that can help to become more familiar with Python, and the official Python documentation is definitely the place where to start. The Open Programmability plugin package provides an API to fully support the definition of mappings for network services within AOC, which enables operators to easily and quickly define the service mappings they want to deploy across the network to flexibly map those services to the actual network configuration that is required on the network devices. The API is composed of multiple packages which cover different aspects of the mapping definition process. The AOC base package and the AOC common package are the packages for operations within AOC. These packages provide methods that enable the management of AOC and service updates, and also to define and manage custom O&M actions related to network devices and services. The event package allows to dynamically retrieve information related to events and alarms generated by the network devices. The NCS package provides the main interface to support the configuration mapping functionality. The SND and SYS packages provide a set of methods for the communication with the devices and support multiple protocols and technologies such as CLI, netconf, restconf, and so forth. Let's get now into more details about the usage of the AOC Open Programmability API developing a service package, or SSP. When customizing the mapping of a service-specific plugin, or SSP, package, the designer is required to inherit the NCS service class. NCS service is a base class provided by the API. By inheriting it and providing an implementation of the NCS map method, the designer can provide the logic for mapping the service Yang definition to Jinja 2 templates, which formally describes the device configuration. In the example of this slide, a simple layer 3 VPN is defined. When making the L3 VPN SSP package, the designer creates the L3 VPN service, inherits the NCS service class, and overrides the NCS map method. The XML to dictionary method is used to convert the input parameters provided to the service creation operation and makes them easily available for this method to process them and eventually provide them into the Jinja 2 templates. During the dry run or commit operations on AOC, the AOC framework will invoke the NCS map method, provide the parameters defined in the SSP YANG model and take the results of this method, which will contain the network device configuration. This is done by a render method, which is responsible for the rendering of the Jinja 2 template that will be used for the device configuration. An example of what can be done with the base package is the definition of O&M actions in the context of the service management. An action can be defined in the YANG model of the service, and the implementation of that action must be provided inheriting and extending the action service class. This action definition can be performed in a number of different contexts, such as dry run, commit, data synchronization, and device data query. An example of what can be done with the sys package is the extraction of device information. The query basic data from DB method, which is described in this slide, for example, enables the extraction of static data related to the device, which describes some properties of the device itself that can be used in the NCS map method, for instance, to generate network configuration parameters. Obtaining real-time data from the device is also possible through the sys package. The query data from device method allows exactly that, and it does it by exploiting the YANG model of the device and then allowing to query the related path within the model. As mentioned, the sys package supports the communication with the devices. The SendCLI method, which is described here, is an example of operation that can be performed in order to communicate with the devices. More in details, it is used for the execution of CLI commands on the device that can be used to extract specific pieces of information out of the device itself. Finally, the event package allows to manage events and alarms from the devices. The event receiver method, in particular, enables the service designer to customize the action to be performed when an event or alarm is received by AOC. This opens up the possibility to customize the reaction to specific events in the context of the service. I hope this video was interesting, and thanks for watching it.